Welcome to the crash course for coding program, which is called Code Eraser. So in this program, first of all, we will learn about an IDE. So our basic focus is on Arduino IDE. So what is an IDE? IDE stands for Integrated Development Environment. It's a software which is used for writing the programs in coding languages. We can write down the programs in a notepad as well, but the problem is that inside that notepad we don't get proper support, proper environment, proper tools which we can get inside the IDE. See, we can exercise at home, but we prefer to go to a gym. The reason because in the gym we get proper environment, proper support, proper equipments are there. So that's why we prefer to go to a gym. For the similar reason, we don't use notepad to write down the programs. We use IDE, which is basically a notepad with integrated software development environment. Okay. Now, once you will open this IDE, you will get this basic structure of programming. You will get two functions. One is void loop and one is void setup. These are the basic functions of our program. Void setup is used to run our code once. So whatever line of code you will write down here inside this setup function, it will run only once and it will remain constant till your program runs. But whatever you will write down inside this void loop, it will run repeatedly. First it will run first line, then second line, then third line, then fourth line. And when it will finish the last line, after finishing the last line, it will jump again to the first line of code and then repeat it again. And that will be a continuous loop, a continuous process, which will never end. Now, here, inside this structure, this space means outside these two functions, void setup and void loop, this space is used to include libraries. What are libraries? We will discuss later. And this is also used to make variables. So what are libraries? What are variables? We will learn later. Setup. So inside this setup function, between these curly brackets, we set up our hardware. Hardware means basically pins. The pins we are using in our microcontroller, we set their pin mode. Suppose our LED is connected to pin number 2. Okay. So what we will do, we will set the pin mode of pin number 2. There are two pin modes. One is input and another is output. Input means if our program is receiving signals from any component to that pin will be set as input because it will receive signal. But if we are sending signal to a component, it will set as output because it is sending signal to the component. That's the difference between input and output. So inside this setup function, we set the pins mode, that pin is used for what purpose. If it is used as input or it is used as output. Another thing that we use here is serial communication. So serial communication is basically the communication between our computer and the microcontroller. In serial communication, our computer and microcontroller transfer the data or exchange the data in series. That's why it's called serial communication. That also we will discuss later about serial communication. So basically inside the setup function, what we will do, we will set the pins mode, input or output. Now the loop function, inside these curly brackets, inside this void loop, we write down the instructions. Instructions is what basically the program that we want to perform with the hardware, that we write down inside this void loop. Now, the next thing that we will discuss is variable. So variable is what? Variable is a kind of box or container which stores any data or values inside it. So inside that box, inside any box that you see around you, you can store any kind of data there. You can retrieve that thing, whatever you kept in that box. You can throw it away. You can add more things inside that box. Similarly, in variables, as I told you, it's a kind of a box. So you can store any kind of a data. You can retrieve it. You can manipulate. You can manipulate, basically delete or add or multiply that data, or whatever you want to do. You can do it with a variable. Okay. So here, as you can see here, this is the box. So this box has a name. So variable is also have a name. Okay. So I have written X here. This 5 is the kind of data which is stored inside this box, which is basically the value. And then data type. Data type means basically to tell our program that what kind of data is stored inside this box. Okay. That's the important thing. Okay. Now the key points about the variable. 3 things are very important while making the variable. One is the data type, that what kind of data is stored inside that box. Data name is also important. And at the end, the value which we will store inside that variable. Okay. Now name of a variable should be follow some rules, like no spaces are there. It cannot start with a number. And there are some rules. One more thing, whenever you will make a variable's name, it should be descriptive, like temperature, speed, pin. Okay, it should be descriptive, because if you will write down any name, so what will happen further in your code, you will get confused that for what purpose you made this variable, that will be confusing for you. So make a descriptive name so that you can easily identify and understand that for what purpose you have made this variable. Data type. Variable can store different type of data. It can store number, decimals, text, strings, true and false, booleans basically. So you have to mention the data type first, then name, then value. So numbers are denoted with int, decimal numbers are denoted with float, single characters are denoted with char, word, series of characters, basically word is denoted with string, boolean is for true and false. Now the language like C++, strongly written languages, in these kind of languages, you have to declare the data type. That is important. And at the end, declaration and initialization. Declaration basically tells the program that you are creating a variable, okay, int age. And after that, initialization is also important. Initialization is basically assigning a value to the variable. So here you can see a variable is created. So 3 things that are important. First is data type, which is int, because this variable is storing a number, which is 25. Data type, then name of the data. So the name of this variable is descriptive because it is storing someone's age. So you can give it any name, but age is the perfect name for this variable because it is storing the age. And at the end, value, whatever value you want to store inside this variable. So that's how we create the variable in the programming. Data type, name, and then value. That's important. Okay. Now let's understand with the help of circuit. So this is the circuit diagram. And in the circuit diagram, there is one LED which is connected to pin number 8. First, we will make a variable for pin number 8 because LED pin is connected to pin number 8. So how we will make this variable? Int LED pin 8, where int is integer, the type of data which this variable will store, and LED pin. LED pin, I can give it any name, but LED pin is the perfect name for this variable because as I told you, descriptive names should be there. So LED pin is defining that yes, this pin is used for an LED. So LED pin, and then the data value, which is 8. So pin number 8 basically. That's how we create a variable for the pin number 8, because our LED is connected to pin number 8. Now let's move further. Now we will set the mode of this pin inside the setup function. Pin mode. Pin mode will define or assign the function to this pin, that this pin will be used as an input or as an output. Okay, so how we will do that? We will use pin mode function. The pin mode function will help us to set the pin mode of the pin as input or output. Input means the data or signal which our microcontroller will receive from the component, and output means the data or signal which our microcontroller will send to a component. Now pin mode function takes the pin name and the mode inside the bracket. So whenever we write pin mode, so it will be written like this, pin mode, then inside this pin name, basically the variable that we have created for pin, we will write down here, then output or input. Okay. So because we are using pin number 8 as an output, because our microcontroller will send the data to our LED to turn on or turn off, so we will set our LED pin as an output. So pin mode function, LED pin, this is the LED pin, and we will set it as output. That's how we set up the pin mode for pin number 8. Now the LED pin, which is basically pin number 8, will be used to send the data or signal. Now we want to turn on this LED, which is basically the instruction that we want to give to our hardware. So we will write down instruction inside the loop function. Now we will switch to loop function. If we want to send the digital signal to LED pin, will use digital write function, and analog signal will use analog write function. Digital signals are the signals that represent the data in discrete binary form, means they only have two distinct values, one is 0 or another is 1. So either our component will turn on or turn off. Okay, it cannot run on different voltages or values. Okay, so 0 means low, either it will turn off or turn on. That's the digital signal. Analog signal is a continuous signal that vary over the time. Okay, we can gradually increase the voltage, we can gradually decrease the voltage. That is basically the analog signal. An analog signal can be sent and received with the help of analog pin or PWM pin. So pin number 8 is digital pin. Analog pin is basically those pins which are marked with negative sign. Those pins are called known as PWM pins. When you have a closer look at the microcontroller, you will find it out. Okay, so pin number 8 is connected to digital pin. Obviously, then we will send the digital signal. So to send the digital signal, we will use digital write function. So digital write function takes the pin name and high or low. High means turn on and low means turn off. So digital write pin name, it will take pin name and high or low, whatever we want to do with this pin, with this LED. Okay, so right now we want to turn on this LED. So we will digital write, we will give it the name, basically the variable, and then write down high to turn it on. So that's how we do it. Digital write LED pin high means it will turn on this LED. Okay, now our LED will turn on. Now we want our LED to turn off. That can be achieved by digital write low command. Okay, if we will write down like this, digital write LED pin low, we can achieve it. But the problem is when we write down that just below the high command, it will execute so fast that we won't be able to see the LED to turn on. Okay. Because as I told you, inside this loop function, whatever you will write, it will be a continuous process. So as soon as this line runs, this will execute it, and again it will jump here. So it will become like a very fast process. So we won't be able to see anything. So to sort this out, we will use a delay function. So delay function, what is the purpose of this delay function? This will pause our program for mentioned period of time. Whatever time we will give it to this delay function inside these brackets. It will pause our program for that time period and then execute the next line of code. Okay, so between this high and low command, we will put a delay function. Okay, now delay function takes seconds in milliseconds. Means if we have to pause our program for 1 second, so we have to write down 1000 milliseconds. If for 2 seconds, then we will write down 2000 milliseconds. So we want to pause our program for 1 second, so we will write down the delay 1000. That's what we did here, delay 1000. So it will pause our program for 1 second on high position and then executes the next line of code. Now in the next line of code, what we want to do, we want to turn off the LED. So we will again use digital write function, but this time instead of high, we will use low. Low means turn off. So what we will do, we will write down digital write LED pin low. Now again the problem arises because as soon as this line of code will run, digital write low, what will happen? It will again jump to this first line of code, digital pin high. Okay, and we won't be able to see our LED turning off. Okay, so what we have to do, we again put a delay here at the end. We will pause our program on this low for a while, and after that it will jump to this high function, first line of code. So we will put delay for 1 second, and then our program will move to the next line of code. That's how we program it. Now, how we plan to code? The first thing we do is to make variables for the pins that we are using. After that, we set the pin mode for all the pins which we are using, input or output, like this. And at the end, we set down the instructions for the robot inside the loop function. Okay, so these three things are the main structure: variables, making variables, then setting the pin mode for all the pins, and then instructions for the robot. That's how we plan our code.